Very good afternoon once again. So last class we have been discussing about Elgamal encryption system, right? And we ended up our discussion up to the proof how the Elgamal decryption process works on, right? So this is a exact procedure, that is, we'll be having a key generation where I will be generating three public values called E1, E2, and P, and I'll be having a private key called D. And we already saw that LGAML is going to produce two ciphertext C1 and C2. Okay. And it is going to have a secret value called R, which is known only to the transmitter. Right. And this is a decryption process. We'll see an example here. So for example purpose, I given a smaller digit, okay, smaller integer values. So here Bob is choosing the value of P to be 11, okay, and E1 to be 2. E1 is nothing but a primitive root, okay. Otherwise, we have a group called a group, okay. Let's set 11 star. Okay, for this group, okay, one of the primitive root is 2, so E1 is chosen to be 2, right, and the private key is chosen to be 3. So they are creating E2, which is nothing but E1 power D mod P. So E1 power D is nothing but 2 power D is 3 modulo 11, which gives me 8. Right. So they got the values of E1, E2, and the value of P is there, and the private key. Okay, private key is 3. We already saw. So in examination, we will be providing values of P, E1, and D, as well as we will choose the secret known to the transmitter. In this case, the secret value is 4. And they are asking you to calculate the ciphertext C1 and C2 if the plain text is 7. Right, so the plain text is 7. Now we have to we have to compute the two ciphertext values C1 and C2. So C1 is nothing but E1 power R mod 11. So E1 is nothing but value is 2 and our R value is 4. So 2 power 4 we got 16. 16 modulo 11 I got 5. C2 is nothing but the plain text multiplied with E2 power R. So plain text we already know its value is 7, and E2. So E2 which we computed we got is 8. So 8 power R. So R is 4 here again. So 8 power 4 gives me 4096. Okay, multiply with 7. So you can use any you can use your calculators to this one. In examination, no need to show how you are going to obtain these values. So I'm getting it to be 6. So these are two ciphertext values C1 and C2. Yes, and you can able to decrypt using this also. You can able to see here they have used C2 multiplied with C1 power D the whole inverse. Right. I got my C2 to be 6, C1 is 5, and my private key is D here. So 5 power 3 the whole inverse. So 5 power 3 is nothing but we have to find 125 inverse, that is multiplicative inverse of 125 under modulo 11. It is 3. So 6 into 3 is what do you get? It will be 18. 18 mod 11 will be getting 7 back. Right. And to find this multiplicative inverse, you can use any method. You can use a Fermat theorem or Euler's theorem, or even you can go for extended equivalence theorem. So here, since it is mod 11, it's a prime number base, you can go with Fermat theorem itself. You can able to easily get the multiplicative inverse. Right. And you are getting the plain text back. Okay. Is it clear, guys, how the Elgamal system works on? Last class we just discussed the process here. This is an example how the Elgamal system works on. If it is clear, kindly raise your hand if you have any doubts, because if and only if you are clear with this process, next slide I will show a simpler way for decryption. That's right. Okay, thank you, Kashish, and thank you, Venkat. Okay. So in decryption part, we are decrypting the plain text using this method, that is C2 multiplied with C1 power D whole inverse mod P, right? So we can able to replace this part C1 power D the whole inverse by applying the Fermat-Little theorem directly, because here the value of p, whichever we are choosing, is going to be a prime number, right? So if you apply the Fermat theorem into this one, you can replace C1 power d minus 1 as C1 power p minus 1. This is actually 1 minus d. So in this previous case, we have our C2 to be 6 and my C1 is 5. Right, 11 is value of p, minus 1 minus 3. So you'll be computing 5 power 7, I mean 6 into 5 power 7 mod 11. If you compute this also, you'll be getting the answer. So in examination, you can choose either this method for decryption, or you can go with, you can go with this method, or you can go with this one. So if you go with this method, only to find the multiplicative inverse. If you go with this one, you have to find the multiplicative inverse. Right. Is it clear, guys, regarding the modification and the decryption part? Okay, I hope it is clear. Right. Now we move on to the analysis part of Elgamal crypto system. So some key points are nothing but here you can able to see that Alice and Bob, that is both transmitter and receiver, have their own secrets. Okay, this is synonymous, like a synonymous you can't say, is somewhat equivalent to our DEF-L1 key exchange process. Right. R and D. R is nothing but a secret known to transmitter. D is nothing but a secret known only to the receiver. So both of them, that is R is going to create C1 and C2 with R without knowledge of D, and Bob is going to compute the plain text, that is decryption process, by having the knowledge of C1, C2 and D without knowledge of R, right? So both are operating in such a way that without sharing their secret, they can able to successfully encrypt the data and decrypt the data, right? So if you see the real-time example, don't worry, in examination we won't give you such a real-time examples. We'll give you simpler ones only, which is worthy for 10 marks actually. So here you can able to see the value of p, which is 155 digit. Okay, generally they work with the maximum of 300 digits. So in this example, I just show 155 digits, and E1 is very small, 2. D comes to be 1007. Now if you compute E1 power D mod P, you can able to see the value of E2 here. Right. So obviously, even if you have a plain text, is very small number, and you are choosing a 6 digit of your secret, transmitter secret, you can see the size of C1 and C2. So here, if they apply this one, then they can able to get the plain text back. So this is how the real-time Elgamal crypto system works out. Right. So now we move on to the next topic called elliptic curve cryptography. I hope everyone have a clear idea about elliptic curve arithmetic. So I have just, kept the same slides here. I hope everyone remember elliptic curves over real numbers. Right? What is the addition process? If I have a point P, how will be computing the minus P? So these points, I think you people are already aware, right? Elliptic curves over Gauss field of ZP, or Gauss field of P, or simply over a set ZP also we just saw. That is by simply adding the model on left hand side and right hand side, and we learned how to plot the curves. So okay, I just added the same thing here. So, and here now I want you people to tell me. So this is like a homework kind of thing. I just want to test how many of you remember how to find the values. Here you have an elliptic curve E13, and values of A and B is unknown. Can you people tell me at least first 5 points in the chat box? I want you people to solve this and let me know, such that I can able to proceed with elliptic curve arithmetic as an application towards elliptic curve cryptography. So I want to test whether how many of you are able to solve this one. So here they ask you define an elliptic curve E13, that's E13 and the 1,1. I hope everyone knows how to find the points. So at least tell me the first 5 points in the chat box. If you have any difficulties or if you have any doubts, you can unmute and ask. At least even if you got any answer, you can post it. At least the first 2 or 3 points, then you can post. Okay, superb question, Ashish. Superb. Right.
Excuse me, sir.
Yeah, Ashish.
So are we like supposed to, can we write 0, comma minus 1 also, or are we supposed to convert it into positive always and write the points?
No, actually, are you getting for 0? You're getting a point, sure.
Like, uh,
Okay, you are getting
yeah,
a
yeah,
0, comma
yeah.
minus 1. This one you are saying.
For minus p,
Minus
like
1,
it's minus
it will
1
be.
plus we add the mod 13 value, right?
Yes, so you'll be
So
getting 0,
are we
comma 12.
supposed to do that always, or we can just write minus p points in negative?
Actually, you have to convert them into a non-negative value. That is, if you're writing 0, comma minus 1, you have to convert them into 0, comma 12.
Okay,
That is,
sir.
minus 1 should be converted into non-negative value.
Okay, sir.
Right. So I hope now you are okay with this elliptic curve points. Right, and this people work it out in your home. Okay. Now, if you are applying this elliptic curve over Galois field of 2 power n, especially this is applied whenever you are dealing with our modern day cryptographic techniques where we will be having only zeros and ones. Okay. So there, what they will do in sense, they will make a small modification for the general equation here, and this is only for your knowledge purpose, nothing to do with the numericals here. Okay, that's just for to give you an idea how elliptic curve is applied over Gauss field of 2 power n. Okay, here we are adding one extra term called hy on the left hand side, and another change is nothing but if you have a point P, okay, over Gauss field of 2 power n, then if you want to compute minus P, it is computed as x plus y. Okay, it's not like x minus y, it's simply x plus y. Okay, so these are two variants. So this is how it will look like. For example, if you choose a Gauss field of 2 power 3, okay, and this is a irreducible polynomial for it. So here everything will be in terms of zeros and ones. And this is only for your knowledge, nothing much to do with this one. Okay, so I will directly go into how ECC is going to be applied. That is elliptic curve cryptography. Actually speaking, elliptic curve cryptography is not like a separate encryption technique. It is like an add-on. How we have add-ons for our browsers for our ease of use, like ad blockers and other stuff. Okay, same way ECC is an add-on to existing asymmetric key cryptographic technique. So one of the things is something where you can able to apply this elliptic curve cryptographic technique over L-gamma crypto system. So as of now, people are clear with how the L-gamma process works on. But if you apply an elliptic curve over this L-gamma system, okay, how the process is going to happen? And one thing people have to remember here, the process of addition and multiplication will be happening over the rules based on elliptic curve arithmetic. I hope everyone knows how addition works and how a multiplication works. Multiplication is like a repetitive addition here. So right, the key generation process, how we will be choosing. Generally, if I go with a general algorithm system, we will be choosing a large prime number called P. But here I will be choosing a elliptic curve. Okay, an elliptic curve with value of P and A comma B. Then I will be choosing a point E1 on the curve. On the curve, I will be choosing any point E1. Okay, this will be X comma Y1. And here D is an integer. This is not a point. This is an integer, and I will be generating the second public key value E2, which is x2 comma y2, such that it is nothing but D times E1. Okay, for example, if you have your E1 to be like 2 comma 3 for your understanding in this writing, 2 comma 3, and by D is like 4, then you have to find 4 times E1 to get the values of E2. I hope everyone knows this is like the same, like given a point P, if you ask to find the value of 4P, the same way you will be finding the values of E2 here. So now it will be shared with the public key, that is the public channel, that is the elliptic curve, the point E2 and the point E1, right? Now if you come into the encryption part, here no modulo operation, nothing comes into picture here. Okay, everything will be over the point and the curve. So here I have the secret value R, which is also an integer value. It is not a point, it is an integer value. So here the cipher text C1, okay, which is nothing but a point on the curve. Only R and D are integers here. So C1 is nothing but R times E1. So you'll be getting the values of C1 here, and C2 is nothing but the plain text, okay, P plus R times E2, and this plain text P will be also represented as a point on the curve. We will see how this representation is going to happen in an example while we are studying. Okay, plus R times E2 here. Okay. Now the point C1 and C2 will be transmitted to the receiver end, and the decryption, how it is going to happen in the sense, I'll be taking point P, sorry, yes, sorry, plain text P, okay, starting with C2 minus D times C1. And here this operation, how it's going to happen in the sense, you have to first compute D times C1. Okay, you'll be getting a point like X comma Y. Next, if you want to compute minus D times C1 means you will be making the point as X comma minus Y. Then you have to add it with C2, right, to get the plain text back. So this is the procedure of adding the ECC to LGAML. We'll see why they have added this one. So before moving into next slide, is the process of ECC over LGAML is clear, or is there anywhere I have to repeat, or the entire process if I want to repeat also I'm ready to repeat?
Sir, for the last part, in decryption end,
Okay.
when we multiply minus d into C1, so we would get minus x comma minus y, right?
No, actually speaking, okay, okay, I will write it clearly so that you get a picture. Assume that the value of d is 3, okay, and you got your C1 to be like 5 comma 7, right? Now first step will be computing d times C1, that is 3C1. So you'll be making 3 times addition of C1. You're getting like a point like 10 comma 14. Okay, this is the point you got. Now if I want to compute, this is like d times C1, you'll be getting this one, right? So now if I want to compute minus d times C1, assume that this d times C1 is equal to a point like q. Now I want to compute minus d times C1 is nothing but I have to compute minus q, right? So if this is q, then if you want to find minus q, it is nothing but 10 comma minus 14. This will be converting them into a non-negative value based upon this value of p.
Okay, so sir, it's like
Then
elliptic curve.
yes, yeah, it's totally
Okay.
wherever point whenever addition, multiplication, or change of sign comes, everything you have to take in terms of elliptic curve arithmetic only. So you'll be getting a some point here, and you'll be having the C2 here. Simply you'll be adding these 2 points to get the plain text point. Tap you.
Okay, sir. And also, sir, you multiplied by 3, so wouldn't it be 15 comma 21?
15 comma 2. Where?
Uh, uh, when you did d into C1, so C1 is 5 comma 7, d is
Okay.
3.
Okay.
So uh,
No,
like we are adding
actually,
5
no,
3
no,
times, right?
actually, the addition is also will be applicable with respect to elliptic arithmetic. This is for your sample I'm writing. I'm not saying the exact answers here.
Okay, sir.
Simply, I'm giving some random numbers. You'll see an
Okay, sir.
example, so you'll get a clear picture. Right.
Okay.
So as I said, the creating of public keys and thing. So you'll be having the elliptic curve E1 and D, and you'll be creating this E2 by D times E1. Right. We'll see an example so that you'll get a picture. Right. So I want everyone to listen to this carefully. If you have any doubts, you can stop me at that moment and ask. Okay. So now Bob is selecting an elliptic curve. Okay. E67 2 comma 3. So in this case, the value of P is 67 and A is 2 and B is 3. Okay. And you will be given the values of E1 and D, and they're giving E1 to be 2 comma 22 and D to be 4. The next step, what I have to do, since I have to find the values of E2. So E2 is nothing but 4 times E1, right? So 4 times E1 in sense I have to compute 4 times 2 comma 22. Can you people let me know the answer? I'll show the formula here. So you can go with. This is a expression which you'll be using. Right. Now am going to find like a moment d times e1, right? D times e1, and the value of d is 4, I think 4, yeah. And e1 is nothing but 2 comma 22. Can you people tell me the answer for e2? For this 4 times e1. So first post me the answer for 2 e1. You'll be getting a point. Then you'll be adding the 2 e1 again twice to get your values of 4 e1 at last. 1 second, I'll just check values of e1. E1 is 2 comma 22. So I'll just stop with this slide actually for your reference lookup table. For formulas, you have the formula for XR and YR. It is fixed. First thing you have to compute lambda. Okay. So lambda, in this case, you'll be using this formula, and the values of A is also 2, I think. So A is 2, I think. So, right? A is 2. right? So if you apply A is equal to 2 and the respective values for E1 and D, kindly let me know the answer. First post the answer for lambda, then you can post the answers for 2E1, then you can post the answers for 4E1 in the chat box. Because if you know general Elgamal and Elliptic arithmetic, this is easy. This is also worthy for 10 marks. Just post me value for this one, lambda for 2E1, then for 4E1. If you're able to do, then you will be getting a clear picture how your ECC based Elgamal system works out. You have the formulas here for your reference. Kashish, you just proceed. We'll see. You want to know the answer for lambda? Okay, 1 second. I have only the final answer with me. If you just check, if you just proceed now. If anyone getting the same answer for lambda, kindly put a thumbs up for Kashish answer in the chat box. Kashish, you just proceed with other values of 2E1 and 4E1. Any answer for 2E1? Okay, Kashish, just tell me if you are getting the same value for 4E1. I think if you try, I think you'll be getting. So just as of now, I'll just proceed with the example. Trying to listen. Yeah, you can try it in your home also. Right. So once you get to the value of E2, right, in this case 13 comma 45, okay, which is computed as a D times E1. Now they will announce the values of E1, E2 and the elliptic curve to the public. Right. The next step, now the plain text Alice want to send is 24 comma 26. Okay. And the secret used is 2. So now you have been computing your C1. I think Kashish, what you got for 2E1 is correct answer. Okay, why in the sense C1, how will be computing? C1 is nothing but R times E1, right? So R is 2. So 2 times E1, which you would have already computed here, is nothing but your value of C1, 35, 1. C2 is nothing but R times C2, sorry, R times E2 plus the point P. So if you do the calculation, I want everyone to try it in your home. R times E2, R times E2 is nothing but 2 times the values of 13, 45. Okay, you people just try this and you'll be getting the values of C2 to be 21, 44. So now this C1 and C2 will be received there. Right now, what we have to do in sense the decryption part. Okay, decryption part we know that the plain text is nothing but C2 minus D times C1. Okay, Kashish, I think now we will can able to understand. So D times C1, D is nothing but value is 4. So first they computing 4 times C1 and they get 23, 25. Right. Now they invert the points. So 23, 25, if I make it as 23, minus 25, that is a minus of D times C1. Okay, if I convert this minus 25 into a non-negative value, because this is 67, so 67 minus 25 will give me is 42. Right. Now what I will do is I take C2, which is 21, 44. Okay, and if I add this point with 23, 42, you will be getting back your plain text as 24,26 back. Right. Is it clear, Kashish? And other guys only Kashish?
Yes, sir.
That's fine. So so I want everyone to work it out in your home. Okay, this is worthy for 10 marks because here we are having a combination of both LGAML as well as ECC. If we are giving small values of D and E1 and other stuff, you will be getting numericals on this one. If you are getting only LGAML system, means minimum you'll be getting 4 digits of prime number P and 3 digits of other numbers. So there the calculation part is heavy. Here the calculation part will be easy, but only thing is something you have to follow the flow of the ECC with LGAML system. Okay, so one thing I want to portray here and says, sir, what is the need of adding this ECC to LGAML system? In the sense you can able to see the size of the keys can be very small compared to the size used in LGAML system. The basic idea is something that you can able to infer from this graph itself. And this what are the, okay, I'll go with this one, which we people solved. So even if you are able to get half of the key size, you can able to replicate the rest of the key. Okay, half of the key size will do the operation of entire set of keys. So that's why you can able to use the smaller digit numbers, so which can able to create your better encryption process. Right. So this is a comparable key sizes for the symmetric key systems. So if you have any symmetric key system, for example, you have 56 bit as a key size, and if you're applying ECC to it, it will run for 112 bits. Okay. So RSA algorithm, which there is another algorithm DSA, we are not coming for it. RSA will be using 512 bits, and you can able to see here this is symmetric key. Okay, they have 56, 80, 112. But if you compare these two, there's nothing but an asymmetric key cryptography system, and this is any asymmetric key cryptography system. If you are appending ACC for a length of where you are going to use 15,360 bits, okay, it can be replaced with simply a 512 bit key in ECC appended system. Right. So with this, I will wrap up today's session as well as the ECC based LGAML system. I will upload the PPTs here up to today's class. So I request you people to try this ECC based LGAML. Okay, so that in the next class we'll move on to the next topic. Right. So I think anyone have any doubts in today's session? If you have doubts, you can ask me. If it is clear, then you can leave the class. Thank you, guys.